So the only properties we're really interested in right now are the tileset image, the position X and the position Y, and the ID. So those are the only ones we're really going to use in this tutorial. So we'll just add them really quickly. So I'm just going to go through this quite quickly because it's going to be, otherwise this will be a very long tutorial. So I'm just going to create member variables. So you'll also be needing a parent object, as we saw earlier. So we're just going to call that the parent, m_parent, and it's a variable, and that's just a tile set. And then we'll need the identifier number, which is just going to be called MID, and that's just an int. That's this ID over here. That's the ID we are interested in. And then we're going to need the tile size and the tile position. So tile size is actually going to be a point object, which is just an X and a Y object in one variable, which is quite a handy little thing because otherwise we'd need two variables. And the tile position, likewise, is also a point because it's an X and a Y too. So we just use that point just to compactly represent that. And then we can assign these things. So in the constructor, all you need to do now is set the parent, like so, and then the ID is equal to the XML element. Now the XML element we parse it once again just using exactly the same syntax as before, and because we already know we're in that element, we don't have to use dot dot. So we're literally once you'll see in a few minutes how we do this, but this XML element directly represents that. So that whole thing, and the only attributes are the ID, the width, and the height. So just using the operator, we can access those very easily. So now we can do the tile size and tile position, knowing how that works. So m_tile size will be a new point object because it's a compound object. And once again, we can use similar syntax. So XML element dot width. So that's this width over here. We're going to pull out using the operator, and the same for the height. So the two arguments that the point constructor takes are the width and the height, just like that. And that's not working right. Okay, there we go. And the width and the height. And very similarly for the position of the tile. So once we go back and we look at that, we'll actually have to do something slightly different here because the position of the tile, the pos X and the pos Y, are not attributes of this tile element that we were just looking at a few seconds ago. So they are not attributes of this guy. They're actually part of a child element. And E4D syntax actually gives us a handy shortcut to doing this. So we know they're in a child element of this tileset element that we're currently working with. So all we need to do is just get rid of these because we're doing a new one. So they're in the XML element. They're a child of the XML element. But they're actually in the tile set image sub element. So using the dot gives you the child sort of sub element. And now, once we've done that, we're inside this element, and now we can just access the attributes directly. So once again, we can just use the syntax. So we just do an like that, and we can use pos X and pos Y. So that's quite easy to understand. So that'll create it for us. And let's just do a quick trace of that as well. And we're going to do it in a couple of lines, so it'll be long. Param. And the ID equals an ID. And then the pos X. Tile pos dot X plus the pos Y. So we want to check, sort of verify that all this is being loaded up properly because it'll be absolutely crucial to our later loading progress. So now we've created this tile params skeleton class with a few attributes in it. Let's have a quick look at our diagram just to give you a better idea of how we're going to be using it and what the relationship is. So this tile map class that we're building is now going to have another member variable called m_tile params, which is going to just be another dictionary that contains a bunch of these tile params objects we just created. And they're each going to have an individual image stored in them, which is taken from the tileset image, as you can see here. And they'll also each have their own index. So that's what we're going to be doing. We're actually going to be loading these using the tile set tile elements, we're going to bind each of these to a single image, which we can then later on use to draw them really quickly. Go back into tile set, and we need to create we need to go back into tile map. Sorry, we need to go into tile map, and we need to do another for each loop that will actually load each tile element. So I'll show you how to do that. So just where we were working earlier, after this is finished, we can load each tile element. So another for each loop, and we'll just call this one's iterated tile, and it's, as usual, it's an XML object, and that's going to be in my XML. And what we want is every tile set tile element. So let's just go through that again. So we're in my XML, which is this guy. That's the root element. And somewhere underneath that, it's going to give us a list of objects which have that name, a list of elements which have that name. So that will match each of these guys in turn. So we can iterate through each of these guys, and we can access their child elements directly. So what we're going to do is we're actually going to create a new tile params object. Let's just start out sort of from the inside out. So we're going to create a new tile params object. And as you saw earlier, we actually use the dictionary which contains our tile sets, and that is bound using key value pairs of file names to tile set objects. So the very first parameter that tile params wants is a tile set to bind it to, as you saw in our diagram earlier. So this is very easy. All we need to do is we just use the tile sets member, and we're going to use the bracket operator, and we're going to pull out a matching tile set with a matching file name. So this is really easily done. Because we already have our iterator, we already know what the file name is over here. We just have to use the same syntax we used earlier. So that's the dot syntax, and we use the file and we turn that into a string. So this looks like a fairly complex statement, but it's not really. It's just saying, just give me a matching tile set object from the dictionary we loaded earlier using this file name as a key. And then obviously we need the tile iterator. So tile params, let's just review its arguments. It takes a tile set parent, which we've just discussed, and then it takes an XML element, which it loads all of its stuff from. So what it wants is this guy. That's what we're passing into here. And that's what this accomplishes. And once that's all finished, we have a completed tile params object. So I'm just going to save that off as a separate variable. And that's a tile params. So we're just going to save that as a separate variable. We're not going to do it inline like we did with the previous one, just to make things a little bit clearer. And that's very simple. So now the next thing we need to do is to create a dictionary to store all of these newly created tile params objects, because there's probably going to be a lot of them. So we're just going to create another dictionary. We're going to call this one logically m_tile params because it's a number of them. So that's all of them, and that will just be a dictionary too. So these dictionaries are actually very flexible, and they're a really, really quick and easy way of just storing things and forgetting about them and coming back later and accessing them really quickly too. So just over here. So the first thing we need to know is like what's going to be our key and what's going to be our value. So in this case, the key we're going to use is going to be the ID. So we're going to map an individual tile set params object. We're going to map this whole element to the ID. So that's how we can identify them. We're going to say, I have ID 1, for instance, so give me this whole object, and in turn this object will know what its parent tile params is, and so on. So we're just going to save the identifier into a separate variable, just to make things clear. We don't have to do this the way. You can do this all in one line if you wanted to. And it's just going to be a string. It could be an integer too, but we'll just go with a string for now. And so it's going to be the identifier of the tile, because we're currently iterating through this guy. So we can just use @ syntax to grab that attribute. So it's going to be that identifier, convert it to a string. And you could convert that into a number if you wanted to, but the string will work just fine too. And it's not happy with what I've just done there. Oh, that's because I didn't put the equals in there, so I'm not actually assigning it. That's better. Okay, so now we have the identifier of our tile, which we can use as a key. And what I'm actually going to do is just pop it into the dictionary. So we've already made the dictionary, and we're just going to use that tile ID as the identifier, and we're just going to make it equal that params object we created earlier. So this is the big params object, which is going to contain a lot of stuff shortly. It's just being assigned to that slot in the dictionary using tile ID as its key. And last but not least, before any of this will work, we have to create a new dictionary to put all this stuff in, because it's just going to be null if we don't do this. So the tile params is just a new dictionary. Just easy, very, very easy, just like that. And that should work. And let's just put a quick trace in there and make sure that all of the stuff that we just did, which is quite a fair amount of code, actually works. This is, you have to be very careful. So adding tile param object m_tile params, just so that it looks nice when we print it out, tile ID. And that's right, that's all we need to do. So let's run this and see how it goes. So let's go back into Flex and see what happened. So it's actually gone back into this other perspective for some reason. So we'll just go back into the console and see. So things are actually looking really good. We'll just make that a bit bigger so you can get a better idea. So it's loaded tileset XML. It's found a tileset image, but as before, it's found the tileset element using that file, and now it's started loading up our tile params. So that's actually looking really great, and it's adding them to the dictionary too. So at the end of this process, we should have, you see these are the keys it's using, 1, 2, and 3. So later on we can just use that expression, m_tile params 3, just to grab them. And that's all looking really good. I'm very happy with that. So now that we've loaded all of these tileset elements, we need to remember that we're actually still loading a whole bunch of other stuff. So there's a lot of loading going on here, and the thing that's currently happening is that the tileset objects, if you go and look at their class, they're still busy loading their images. So their images could be loading at any time. And what we need to do is we need to figure out a way to determine when the images have all finished loading, because we could have more than one tileset. So a really easy way to do this is just to add a member function to the tileset class called isLoaded. And this is going to be public because I'm going to be calling this from outside code. So actually what's going to be calling is timeout. So it's just called isLoaded, and it just returns a boolean. And it's very easy to check if this tileset has finished loading, because its m_image object will be non-null when it finishes loading. So as soon as onLoadAlready is called, it's going to set m_image to a non-null value, and in ActionScript all values that are not explicitly initialized start off as null. So if we keep calling this regularly, we'll eventually see that returning true once the image is finished loading. So now that we have this isLoaded function, we need to find a way to determine that all of the tile maps have finished loading. And in order to do that, we have to actually poll this very frequently, because the tile maps may load very quickly, so we want to cover that case, but we also want to wait long enough for them all to load. A really easy way to do this is if we go back into the tilemap class, we can add an event listener that gets called once per frame. The default in Flash for the frame rate is 24 frames a second, so that's really quick, and that will be pretty much what we need for this case. So I'll show you. It's really straightforward to do. All you need to do is find a place where you can add that event listener in. And because we already have a parent sprite, which is a sprite object, we know that the sprite object has a stage member to which we can add this event listener. So all we need to do is just call the parent sprite's stage member, and it has an add event listener. And the type that we want is event.enterFrame. That's the beginning of each frame. So 24 times a second, this function is going to get called. It's sort of the heartbeat of our program. And we're just going to give it an arbitrary name. We're actually just going to call it enterFrame listener. So now we just have to declare that function. And we're just going to put it right over here. And once again, like most event listeners, it just takes an event argument. So we're just going to call that event, EVT. And it's just an event, so very similar to the previous functions. It doesn't have a return value. So this is very straightforward, and the name makes it easy to see too. So just to demonstrate how this works, I'm going to just do a quick trace so that you can see how this tile set that is loaded works in action. So what I'm going to do is I'm going to loop through all of the tile sets and create some code that can sort of detect when they've all finished loading, because that's one of the conditions we want to move onto our next stage. So first we have to make that condition work. We have to make sure that that test is working before we can use that test to progress. So this is a very simple loop. All it does is it goes through every tile set, and if any of the tile sets are not loaded, if any one tile set is not loaded, it will return. So logically, if we get to this oh, if we get past this loop, all of our tile sets have finished loading. So let's just do a little trace there and run that, and let's see how that goes. What we should get is a huge spam output log as soon as all the tile sets loads. Because we're running locally, that'll be virtually instantly. So we'll just go back into Flex so that you can see it as it happens. And I'm going to go into the debug perspective. And right there you can see it's logging like crazy and it's spamming the output. So the tile sets have loaded, and every frame it's basically telling us that they've loaded, which is great. That's exactly what we want. Now we're going to use that in order to make our state machine work. So what I'm going to introduce you now is the concept of a state machine. This may already have been discussed in previous tutorials, but we'll go over it again over here. And it's really simple. We just want to have one state that handles each section of the loading, and we want to progress to the next state once that section is finished. So this really ties in very well with this sort of asynchronous model where we sort of just polling it continuously. So the first thing we need to do is figure out which states we're going to have. So I've already sort of thought about it a little bit. And the states that you need about 4 or 5 different states to make all of this work. And it'll become clearer as we progress in the structure of the program why it's structured this way. As you see all the pieces coming together, you'll begin to understand why you would need so many states. But it's pretty obvious which states we need to start off with. We can just define one for everything we've already done. So we've already figured out how to load the root XML file. So I'm going to make that into a constant. We're going to make a bunch of these constants, so I might as well copy this. And the next state we have already defined in our code implicitly is when we are loading the PNG images out of the tile set. So we call that loading tile set. Maybe the names are not perfect, but they'll do for now. We can always come back and change the names to be a little bit better. Often you don't really know what your state machine does until you've written it for the first time, and then you have to refactor the code to be a little bit better. So the next state we want is when we are loading the tiles. So that would be loading the map.xml file. So we call that loading tiles, because really that's what we're doing. We're loading the actual tiles in, as opposed to the tile declarations and the tile params. Last but not least, we're going to have a state called state running, which is the state we reach when everything has finished loading and we are ready to display. We'll also need a member variable called m_state, just to contain the current state. So that will literally just say what our current state is. And that guy is going to start off with our very first state, state 1, which is when we are loading the root XML. So we're actually going to be sort of wrapping all the code we've already done into an existing state machine, just so that we can make everything a bit more homogeneous. So we're just going to pop it in here. In our constructor for tile map, we're going to set our first state to be state loading root XML. So that's something we've already done, so that's great. Now, once we come back to our enter frame listener function, it's going to get called very frequently. What we're actually going to do is turn this into the workhorse, sort of the heartbeat that delegates control to different states and decides which state we should be in based on our current data. So it's a very straightforward way to do this, and a very common way to do this is to have a switch based on your current state. And every frame you can do something different for each state, which is a really powerful way of implementing a state machine, and it's very common in the games industry to do it in this way. So what we basically need to do is just add a case over here for each state. I'm just going to indent that a little bit. So this is probably not right what I'm doing here. We're probably going to rearrange this. I just need a place to put this temporarily, so that'll work fine for that. And I'm just going to do this for every state. So just for the other 3 states. Loading tiles. Oh, that's actually a later state. What we want is loading tile set. That comes before. So we want to try and sort of have this in pretty much the same order as the states appear as statics, just to make it a bit. It would be pretty confusing if they weren't in the same order. It would be not look very good for the programmer who was writing it. And last but not least, we have state running, which there is no other option for, so we just use that one. And I'm beginning to suspect that I have too many or too few braces. Yes, I do have too few braces because of the way that autocomplete was working. Great, so now we've got these states. Each of these states can be processed on a per frame basis, which is really handy. We can do some very, very fine-grained loading and behavior switching, and it will all be real-time, and the user will have a very good experience. So now we need to get the ball rolling a little bit. Since at the beginning, once our tile map is constructed, we are in this state, the loading root XML. We already know when we want to switch into the loading tileset state. That's when we begin loading the actual tile images. So this is very straightforward because we already know when that happens. And that's right at the end of the the function that actually loads up the tileset.xml file. So here we are in this state, but we want to switch to the next state, which is loading tileset, which is loading the actual images. It probably could have a better name, that one. So all we need to do is at the end of that function, we know we've loaded it, so it's ready to go into, we're ready to go into the next state. And just like that. And since we're doing this 24 times a second and checking this value very, very frequently, the next frame will switch into the state and it will start processing the info in that state. And it's in that state, we actually don't really need to do much for this particular state. We may actually even remove it later on, depending on how it works. It's in this state where our images are being loaded and where this function becomes relevant, because this function only really applies in this state. So what we want to do is we want to move out of this state and into the next state as soon as all of our tile sets are loaded, which, as you saw before, is where this little trace comes in handy, because this is, we've identified the exact point where we want to move into our next state, because that's where all the tiles are loaded. So all you need to do here is just set the next state, and the next time it comes around back into this function, bang, you're in the loading tile state. So that's really cool. And the other advantage that, actually, I'm going to leave that trace in there because it's quite a handy little trace. Oh, what happened there? Okay, it's quite a handy little trace, and we still want to switch into the next state. And if we run it now, you'll see that this is only going to be tracing once. So it will only ever tell us once ever that all the tiles are loaded, which is exactly what we want. We want to only show that message once, because there's no need to show it 1,000 times. And if we go back into Flex now, you'll see it once. So it's moved into the next state, and currently, if we put a breakpoint right over here, you'll see that it hits that breakpoint because it's now in this state. So now that we have our state machine working really good, we're just going to terminate that. And there's one more little thing we need to do in order to really finish up this particular state of our program. So it's 90% complete. What we now need to add is, just before we switch into the next state, we actually have to copy our images. So if you go back and you have a quick look at the diagram, we're now going to be able to show you a more complete view of what the diagram will look like. And you'll see that each of the tile params actually contains a sub-image, which is a bitmap of the parent tile sets image. So that single image is going to be blasted onto the screen really, really quickly, instead of doing a rectangle copy, because rectangle copies are much slower. It's much easier for Flash to optimize that. So all we really need to do now is to actually just give these tile params their own little image. So we're just literally gonna copy a region of the parent's image and create a whole new image. And I'll show you how to do this. So the first thing we need to do is we need to loop once all of our tile sets have finished loading their PNG images. We already have all of our tile param objects created for us just over here. So this right over here has already happened. So our tile params are ready. They just don't have images that they can draw yet. So we have to give them these images which are based on their parent images. So what we're going to do is we're going to do a loop for we're going to loop through all of these tile param objects which we already have loaded. We'll just call the iterator tile param. And it's just a tile params object, and it's just in our dictionary of tile params. So we're going to loop through every item, every value, key value pair in this dictionary, and we're just simply going to call a little function. So we haven't got this function yet, but we know exactly what it will do. So what we want to do is we want to copy the bitmap from the parent. So we'll just call it copy bitmap from parent. It's sort of programming in advance, you might call it. So we know what this function does. It's very straightforward. So we can copy that name and go into the tile params object. And in this object, we're going to give it a member function, a public member function, which we can call from outside with that name. And it doesn't take any arguments, doesn't return anything. It's just a little helper function. And all that it does is it copies this bitmap. So the first thing we need to do is actually give tile params an image that we can copy something into. So we're just going to give it a private member variable called tile image, m_tile image. And that's just a bitmap data. That's the really low level one. And you're going to see where we get into the low level work in a second, as I discussed earlier. That's why we can only copy things between bitmap data objects. That's why tile set has a bitmap data object instead of just a plain bitmap. So if we come back into tile params, now we can start using this bitmap data to the full. So first of all, we need to create that image. So since we don't have it, it's just null at the moment. So once this function gets called, that's a good place to do it. So we're just going to new it, tile image equals a new bitmap data. And now we need to know how big this image is going to be, the width and the height.
And we already know what it is because previously we loaded the tile size. That's the size in pixels of this particular tile, which is a subset of its parent. So we can just use m_tile size and it will tell us how big it needs to be. That's how we did all the work earlier to load it. So it's really, you're really starting to see how this all fits together. It's sort of like a jigsaw puzzle that you really have to think in advance about. And I don't think I have a using for bitmap. Oh, I do. And now let's see why it's not happy with me. Oh, that's right, I actually spelled that wrong, my mistake. m_tile image, that's better. Alright, so now that we've created our little image of the correct size, we are going to define a rectangle within our parent image, which we want to copy into m_tile image. So we're going to make a sub-image basically. So we just call it sourceRect, and it's just a temporary variable. We're not going to use it after this function. It's a rectangle, so autocomplete that and make sure you get the using for /geom rectangle. And it's going to have a pretty complex definition because we're going to have to do a bit of careful work here with the coordinates. So I'm going to put in a bunch of different lines. The very first coordinate we want is the top left corner of the source inside our parent image. So if you go and look back at our parent image, just to refresh your memory, what we're basically going to be doing is copying a section of it. So let's say we want to copy the leftmost tile here. So we just want the section right over here on the left where my mouse is going. We just want that area. So first we need to define the top left hand corner of our source rectangle. So that is very easy. You just copy here and we already know where it is because it's the tile position. So it's m_tile pos, which we loaded earlier. That's from the XML. That actually tells us where in the image this source top left hand corner is. And we just do the same for the Y. So that's our top left corner of the source. And then all we need is the width and the height, which must be the same as our tile size because that's how big our tile is. It can't be bigger than that. So we just use the tile size once again, and that's all you need to do. So now you have a source rectangle which we can use in our copy command. So that's the last stage. We actually have to copy the pixels into our new sub image. So we're going to copy from our parent into this object's m_tile image, and that's just done using the copy pixels API. So this is actually just a member of tile image, which is a bitmap data. It has a function called copy pixels. It has a lot of functions that do similar things, but copy pixels is our man at the moment. And this, once again, is a pretty complex function, but its arguments are very simple if you just go through them stage by stage. So the first thing we want is a source bitmap, which is our tileset object, which we loaded earlier. And we know it's finished loading at this stage, so we can access its internal bitmap data object. So all we do is we call parent.getImage. And I actually just have to go and check. My mistake, it's m_parent. I'm so used to I'm used to doing C#, not Flash, so that's the convention there. We just have to check, getImage we may not have defined this yet, so that's just sort of a standard function that I put on pretty much everything with an image. And I'll just give it a getImage, and getImage is just going to be a public function that returns a bitmap data. So we're peering into this object and we're saying, alright, give me your bitmap if there is one. So all we do is return mImage. Easy as that. And now our child tile params object can use that getImage to grab that bitmap data and use it for its own purposes. The next one we need is a source rectangle within this parent image from which we are going to copy, and we've already defined that because that's just source rect. So as we discussed earlier, so pop that in there. And then we need a destination point. So we want the exact top left hand corner of where in our destination image, which is tile image, that's our destination image, that's this object's image, where we're going to be placing this block of this rectangle of copied pixels. And this is just going to be right in the top left hand corner at 0, 0, because our image is exactly the right size, so we don't need to offset it at all. So we just want it right in our top left hand corner, and that's it. So now you have a very useful copy bitmap from parent method, which we can call from tile map, and that should all work. So that's going to create these little sub images which we can then draw very quickly without having to do this. If we didn't do this copy from bitmap from parent on loading, if we didn't do it just the once, we would actually pretty much have to do this each time we wanted to draw every single tile grid, every single tile in our map. That's potentially hundreds, if not thousands of tiles that you're going to be doing copy pixels for. And copy pixels is not the world's fastest function. It's a pretty slow function because it deals with a lot of data. Potentially these could be huge amounts of pixels. So you really want to sort of do this as, cache it up beforehand. And actually, once the image is copied, an entire image can be displayed very quickly by Windows' GDI layer. So that's sort of a big optimization that we can do to make things easier. And it makes other things easier too, as you'll see later, because we have these sort of very easily manipulated little single images. So that's done. Now we're copying these, and these images are going to be very happy with themselves because they can be drawn really quickly. And then we set the next state. So let's just give that a quick test and make sure it works, just so that we can see that it doesn't crash or anything. And it's hit my breakpoint. So it's hit this breakpoint, and that's fine. And if you look, this state, it's only possible to come into the state once we have finished the previous state, which is loading tile set, and once we have finished copying this. So that means that our copy bitmap from parent has worked perfectly. So we'll just terminate that. So now things are really starting to come together, and what we're actually going to do next is load up map.xml, which, as we discussed earlier, is just a bunch of indices, and these indices are the same as the ones that we've just all finished doing a lot of work to load up. So what we're going to do is we're going to match these indices to the bitmaps that we just copied, and we're going to display those bitmaps. So it's actually really easy, and there are a few steps to it, but it shouldn't be too difficult to do. So the first thing we need to do is actually load map.xml, and we can just use a URL loader to do that. So I'm just going to do a trace. And we know the name of it because we saved it earlier when we were constructing our class for the first time. And I think I'll put an extra plus there. There we go. So it's just going to be a standard, pretty standard URL loader, just like the last time. We're just going to need a URL request again. So what I'm actually going to do is I'm going to copy the previous one because it's so similar. We could probably even turn this into a little function, but that's not really necessary. And the path, the only thing that's really different is the path. There we go. And also the callback function will be different. We'll create a new callback function called URL loaded tile map. So let's just declare that function. We're just going to declare it after URL loaded tile set. It's once again, it's private because we never called it from outside. And just like the previous one, it also takes an event, and it doesn't have any arguments. It doesn't have any return. It doesn't have any return values. It does have an argument. Okay, and then we'll just do a quick trace to make sure that we have loaded it properly. Excellent. Okay, so since it's XML, as usual, we're going to need an XML object. So let's create that XML object. It's just a standard XML object like before. In fact, we can even copy the earlier one to a great degree. This function is going to be very similar. We'll just do a slightly different job. So there we go. We don't actually need to massage this XML because in this file there is no malformed XML. It will load fine. Now that we've got that, we need to make a couple of variables in our tile map class. We need to represent these 4 elements as integers because we're going to need them to determine how many tiles we have and how big our array is. So we're just going to create some little variables for them right over here. So they're just going to be points, and we'll call size, that's the number of rows and columns, that's just the point. And likewise we'll have another one, tile size in pixels, also a point. So size will just be the rows and columns, and tile size in pixels is this one. So that's what they really are. They're not very well named in the XML, but we can sort of get ahead of them. And just in the tile map constructor, we just have to construct these guys. So we're just going to set them to 0. So we're just going to create a new point for each of them. Just set it to 0. Just like that. So now we can use them. We can start loading things into them. Let's go back to our loader method. Okay, so this is really easy. We're just going to load them directly using E4D, just like we did before. And there's a tile map element, as you can see here. We want the very first one. There only will ever be one. And we want the attribute called columns. And the same for the Y. So that will be the rows. So this is our rows and columns size. And then tile size in pixels is very similar. We can actually, so similar we can actually cut and paste it. And these are just called tile width and tile height respectively. And that's the Y. There we go. So now we know how big our map is. Now we need to go back to the XML and see what our next stage is. And that will be to load the individual layers. So there could be more than one layer. It's very possible that there could be more than one layer. So we only happen to have one in this file. but there's no reason there couldn't be more. And for us, it's very trivial to support having multiple layers. All we need to do is create a list of them. So we just do that by creating a dictionary. Oh, I'm sorry, not a dictionary, an array, because we know how big it's going to be. And we have to create that in the constructor, just like the other ones. Layers equals a new array. And now that we have that array, we can start to populate it in our loader method. So just right over here. All we need to do is create a loop. So we're going to be looping through the XML elements. So we're going to create an XML iterator, and it's going to be looping through the tile map, the very first tile map, just like the above. And we just want all the elements that match the name layer. So that'll be all of these guys. So we want all of these layer elements. So there could be more than one, and this loop will ensure that we get all of them in the order in which they appear. So now we're just going to do a quick trace and make sure all of this code we just wrote works. So we just want to load. We just want to say which layer we're loading, and the layer actually has a name. So we can just do layer.addName.toString. So that'll be this name over here. Name equals layer 0. We can actually just print that out just to make sure, and it's probably something that you'd want to save later on, because layer names are really useful for debugging and so on. Let's just give that a quick whirl and see if it works. No, it doesn't work. It's not very happy with us. There's an error in here somewhere. Let me just go and have a quick look at the errors. Problems. Yes, we do have problems. We have deep trouble. Oh, I don't actually know where the... Oh, there it is. There it is. Oh, of course, the return value cannot be void because we're returning a bitmap data, not a void. Very silly. So let's try it again. Sorry, that was my mistake. I should have returned the correct type. Now if we go back into Flex, let's have a look at our log. And there we go, that's what we want. It's loaded map.xml, and it's loaded the very first layer for us. So a lot of stuff has had to work for that. So it's loading tile map layer 0, and that's the name of this guy. So now we need to load the contents of layer 0, in fact for all the layers that may or may not exist. So we're going to stop that. And let's go back into tile map, and back into our loader method. Okay, so now we're in this loop of layers, which is cool. Now we just need to create a little bit more stuff. So we've already created this array of layers, so now we're going to populate it. So for each layer that we find in the XML, we're actually going to create another array. So we're going to have an array of arrays, because we need an array to hold each layer's data. So each layer will have its own little internal array, you might say, which is quite straightforward to do. You just create an array like this, and we know how big it is already because we loaded the rows and columns, so we can just use them. Just like that. That will create a correctly sized array to hold all of our indices. So we'll be able to put all of our indices in there without any trouble. And then we just have to push that into the layers array, like so. So as we go through in the order in which they appear in the XML, layers will get all these blocks of data pushed into them. And later on we're going to use this. We're going to use this in our drawing code too. And now we're ready to load up these indices, since we've got an array that we can put them into. But they're just going to be stored as integers. So all we need to do is we actually need to loop through each row and each column, which you can do just using 2 nested for loops. And we're just going to do x and y, they're integers, and they'll be bounded by the actual size of the rows and columns elements, and just like that. And they're very similar. So we're just going to cut and paste that one and modify it to be the x. They're virtually identical, except they iterate through a slightly different thing. So for each row, we're going to look at each column. And inside this is where the real action is going to happen. This is where it all comes together. Because now we can bind together all of our different pieces of data into actual tile images. And this is going to look great when we're finished. So the first thing we need to do is actually have a regular expression that will identify these numbers. Now, a lot of people might say, oh, just, write a function that has a cursor or an integer that tells you the current offset, and just look for the comma and that will be a number. But I think I actually tried that, and it was really more work than it should have been, because I had to deal with white space and I had to deal with all sorts of things, like maybe there will be a negative number, who knows. So a far better way to do it is just to use a simple regular expression, which already deals with all those things for you. So we're just going to go up here above our little for loop, and we're going to create a regular expression, and it will just look like this. Alright, I'll type that wrong. And we'll create a new regular expression. It's a very simple regular expression. The best regular expressions are simple, but it's sort of what it does in the background that's quite complex. Dealing with the white space in that for me it's priceless. It really is. And before we can use that, we have to have all of this data somewhere. We have to have all the indices somewhere in a string form so that we can apply the regular expression and use it to find matches. So we just create another variable called data. That's just a string, and that's going to use the layer, which is the iterator that we're iterating through over here. That's actually an XML element, and we're going to use E4D to grab the data element inside that. So now we're in this element, and in that element we're just going to convert it right to a string. So what that actually does is it converts the contents of the element to a string. So just be very clear on that. The contents of the element are what's going to land up inside this string right over here, data. And we're going to apply this pattern to those contents one at a time to get our indices in a very nice, very robust way. And also in a very concise way, because we don't have a big function looking for the next comma or whatever. So now the next thing we need to do is loop through all of these indices one by one. And that's really easy. And we're just going to be extracting IDs. So let's just put a comment there just to make it clearer. So the first thing we need to do is grab the next match. So this takes a little bit of explanation, so I'm just going to write the code and then I'll tell you how it works. So we need to create a matches object, and that's going to be using our pattern that we declared, and we're going to execute that pattern against the big data string that we just grabbed earlier. So the big fat data string that contains all the indices. But this is very efficient, because it's not actually going to match everything every time, as you'll see shortly. It's actually a lot cleverer than that, and it's a lot faster than you'd think it would be. And now we can create a tile ID, which is just a string, and that's going to be matching our tiles. And that will be the very first part of the matches object. So once again, this is not 100% clear just from what I'm doing. So the way pattern.exec works, and it's a very sophisticated function, it's not immediately obvious what it does. The documentation is pretty vague. But what it does is, when you start out, it's actually got a cursor internally, which starts out right here, right at the beginning of this. It's literally on the first character, so it'll be right there. And internally, when you call exec with our regular expression, it actually only matches the very first little number over here, or the very first regular expression, the first match that it can find. It stores the result of that match into matches, see. And then what happens is matches 0 contains the actual match. So matches has got a bunch of other stuff in it that we don't need, but we just care about the first match. But it hasn't matched all the other stuff. It is literally stopped right there. So it was virtually just a few cycles before it found what it wanted. And then what happens is when we finish this section, it's going to come back into this part of the loop, and then it still has that cursor, because pattern is outside of our loop. It's almost sort of a global in this context. It's not changed. And it's still got its little cursor, but its cursor is now over here. So it's going to be matching the next guy, and so on. So it goes through each index. So it's really, really quick. It's about as quick as you can get, really. And it's still very robust because it handles all that white space for us, which is a real pain to work with. So we've managed to eliminate all of that just by using this simple regular expression, and we get this little index out that we can use. So the next thing we need to be careful of is this number, the zeros. So you'll see there's a lot of them. And they literally mean there is no tile here. So in fact, most of these are 0, which just means that that index is not used. So if you look closely here at our intileset.xml, each of these tile IDs starts at a number greater than or equal to 1. So they're 1 based, which is fine. It just means that that's an empty spot on the map. So we can handle that very easily simply by seeing if we have an object in a dictionary, which we declared much earlier, the tile params dictionary, that matches this identifier. So if we don't, it means we haven't got a tile, just don't show anything there, and that will work fine. So we just test that. If these are all of our tile parameters, and if we don't have one that matches the ID that we just loaded, which is this ID over here. So if we don't have one that matches this ID in our map, so if we can't find a match for that, it'll just return, this operation just returns null. If that can't find anything in the dictionary, just ignore it. So we just put a comment to make it clearer. Just like that. So that'll handle all cases where we just simply couldn't load a tile for whatever reason, and it'll just leave an empty spot on the map, which is far preferable to, e.g., crashing or doing something like that. So now we know we have a valid tile, we can just pull it out of the dictionary. We pull the actual bitmap out of the dictionary. That's what we want. That's what we want to show at this position, because we can use the X and the Y to position that bitmap. And we're going to do something slightly more sophisticated than just copying a bitmap. I'll show you what I'll do. First, I'll pull out the parameters. Actually, the tile params. And it'll come from our dictionary, just like before. It's actually the same test that we did earlier. We could probably make that a variable too, but that's fine for now. And something, I've done that wrong. That should be an equals. And now what we can do is we can actually create a bitmap as opposed to bitmap data. So we're going to call it BM just for short. Now what a bitmap does is, and we'll just make a new one, the bitmap object, if you look at its constructor, is very different from bitmap data because a bitmap actually wraps a bitmap data object. So you can have a lot of bitmaps all having a reference to the same bitmap data object. So essentially, we can boil all of these indices down to the number of unique images we really need, as opposed to what we could have. So that's the fastest and most memory efficient way. And this is where the tile map technique really begins to shine, because we only have 3 images. We don't need any more than that to display our whole world as it is now. Even though we have potentially thousands of indices, we really will only be using 3 chunks of bitmap data, and these bitmaps are very lightweight. They just wrap that bitmap data, which could be huge. They just wrap that very, very easily and very painlessly. So all we need to do now is actually just pull the tile bitmap data out of our tile params object. So we'll go to tile params, and you'll notice that we have a private bitmap data object, which we loaded earlier and copied, and we went crazy with it. So all we need to do is, I've just added this get image method. So you'll just have to add that too. Just add that now. All it does is it returns tile image. So if you go back here, we just use the tile parameters object, and it has a get image. So that'll create out a little bitmap wrapper. And this one is the one we're actually going to, the other nice thing about the bitmap wrapper is, although it represents a chunk of bitmap data, we can set its position independently. So each of these bitmaps can have a different position, and yet they're still referencing the same chunk of data. So the data is not duplicated at all. It's merely drawn in a lot of different places, which once again is a classic optimization of a tile map. And that's perfect for us because it means it's going to be really, really uber super fast to draw these things, because all we're really doing is just changing the position and reusing that bitmap. So let's get right into the drawing aspect of it. So first we need to position the tile based on our X and our Y position. And we know where to put it because we just need an X and a Y for it. So we already have an X and Y because we're iterating through them. So we can use them. So it'll just be X. Then that's the row and column. So that's not in pixels. We need an offset in pixels. So we just multiply that by the tile size in pixels. That's the wrong one. And the X element. So what's happening here is your bitmap for this particular row, this particular grid cell, you know where it is based on the X and the Y, which are computed here in this loop. And all you need to do is take that X and that Y, we're going to do the same for the Y, and multiply it by the size in pixels to get the correct pixel offset. So that's really simple, and that's going to position things along a grid of a regular grid of the same size. And now this is where it gets exciting, because now we just need to make it actually display this bitmap, and that can just be done by using our parent sprite object and adding the child, which is this bitmap that we just made. So that's going to add it to the display list, and it will use this position when it's drawing it. And since we're doing that for hundreds or possibly thousands of tiles, we're going to get actually going to have a drawing. So last but not least, we should save it into this array, which we declared earlier. Later on, this won't be used in this tutorial, but later on when you do things like collision, you'll want to have saved these tile bitmaps, and you want to do things with them. So that's why I'm showing you this, because I want this to be an extensible library. So by doing this, you can come back later and actually just use these identifiers and look things up and do collision with them and go crazy, because the tile params object, you essentially have one of these tile params objects for each of these indices. So you can look up, just using this index, you can look up a big tile params object. It has an image, it has codes, it has tile size, you could pretty much, in that tile params object, you could have all of these things just based on an index, and you can look it up so easily and very, very quickly using the dictionary, which is a hash lookup, so it's super quick. So the place to put this, now this will need a little bit more explanation, is just in this position, and I'll explain this formula to you in a second. So what you want to do is, tiles is a one-dimensional array. Its size is the number of columns times the number of rows, as you can see here. So it's big enough to hold all the indices, but you have a 2D position over here. You could use like an integer that just records, you could increment it every time you go in this inner loop, but that is not really necessary. All you need to do is multiply y by the number of columns and then add the current column, and that will give you the right array sort of cell that you want to put the tile identifier in. All right, I think we're ready to try this out. So let's give it a drive and see how it looks. This is the best part, because we're going to see all of our work come together. And that, I must say, is pretty impressive. If you recall correctly, look at that. You can see, you've probably forgotten what the original tile map looks like. But I'll show it to you again and we'll compare. And now bear in mind that we've done this completely by ourselves. Okay, so we'll just quickly show you how it used to look, and then you can compare with how it looks at the moment. So I've just closed Firefox because it was taking a long time to load tap. We're just going to load up the old test level. Okay, so let's have a quick look at that, just to give us a rough idea of how it would look. And it's running pretty slowly. It's probably because Flex is eating up all the CPU. So look at that. I'll just go back there. So look at that carefully, and you see all these little blocks that we created earlier. And now, if we run our application again, then it should look the same. And this is all being drawn using our bitmap splitting algorithm and loading up the XML. So you could go in and change that level in tat now, save it, and grab the XMLs and place them into the bin debug directory, and it would actually look the same, which is essentially means you have now got a level editor for your game, whatever game you're working on, or even for your application. It doesn't have to be a game, it could be some other type of application. And you could refine this, and you could move through this, like the whole time map is there, you just can't see it because you can't scroll, but it's trivial to add scrolling. You just have to change the X and the Y of the parent sprite. So it's really is that simple, and you could put a character in there or use the collision. You could really go crazy. So this is the beginning of a great thing for you, and I hope you enjoy using this tile map library that we created together, and thank you very much for listening.